maybe visited in geometry. At least this year it will be. But if it wasn't, so yay, and it wasn't because I haven't really touched on it in geometry yet. So, but we are tomorrow. Anyway, so law of cosines, very exciting moment rather than law of sines. Which computer am I on? Okay. All right, oh, there it is. Now, of course, you have it on your formula sheet, so it's all lovely. But these are not proportions anymore. But it is kind of a play on the Pythagorean theorem, right? And if you're looking real hard here, we've got c squared and a squared and b squared. However, because this is no longer a right triangle, you have to kind of take away some of the pieces here. So then you're going to take away two of the things that you already have right here, so a times b. And then because it's laws of cosines, you're going to do cosine of the angle measure that you were trying to find of the side that's squared. I know. So notice that there's a c squared at the beginning and a cosine of c inside of it. Okay, and then there's a b squared on the outside and a cosine of b. So that's kind of the pattern that you're looking for, is that the side length that you're looking for is also going to have to match the cosine of the angle. And then everything else are the other letters squared subtracted out to a b. It actually should kind of reflect, what am I trying to think? Like that area model or the expansion or the FOIL of b plus c squared, b minus c squared. Yeah, b minus c squared. So anyway, the idea is still there. There's just three exact ideas of what if the triangle was right, what if it's acute, and what if it's obtuse. Turns out it works for all of them. Okay, so it's all fine. And so now, instead of using law of sines, even though sometimes you still can, you're going to only be given side lengths, for instance, and going to have to find an angle. And so that's not possible with the law of sines, because the law of sines needs an angle. And so if you don't have any angles, then you're like, okay, well, I'll just use trig. Well, sort of. You're going to use law of cosines trig. So.
Is that not real trig, Maggie?
It's a fancy trig. So
it's it's like trig, you take away half of trig and then you put a lot of frosting on it.
Yes, yeah. And some glitter. Edible.
Oh, I like glitter.
Yeah, there you
go.
Edible glitter, yeah. It's
Do you have any? Can I have a sticker?
Sure, later.
Thank you.
Okay. So here we go. Also, really annoying picture because 20 degrees is in here, but it looks like it's, I don't know, in the middle of the triangle. So anyway, so potentially we could actually use law of sines to do this diagram, okay, because we're given angles and side lengths, yay, but we're going to solve it using law of cosines. So you could check your work with sines, but
I don't actually think you could use law of sines in its current state.
In this one?
Yeah.
Yeah, you can, because you're given an angle.
Maybe you don't have an angle on its corresponding side. So
Oh my God, you're right.
Oh my God, Lex.
No wonder we can't do it. Thank you, Lex. Okay, so in accordance with what Lex said, we can't use law of sines. So
Big brain Lex.
I know.
I just know how to look at numbers.
Well, I don't. Do you?
Letters.
Do you?
Yeah, because usually the
I've
opposite side was given the angle.
Clearly you don't.
Clearly, thank you. Okay, sometimes we like to be redundant, but today we're not. Okay. So that means that we are going to use, let's see, well, we have c as the degree measure. So that means that we are going to use the one that said c squared. Because otherwise you can't end up having a cosine of the angle because you don't even have the angle. So we have to use cosine of c. So this is going to equal, from the formula, minus 2ab, all of that multiplied. Hopefully this here you realize is all multiplied. Kind of should remind you of the quadratic equation where you had like the square root of b squared minus 4ac. Anyway, there's this huge long thing that you need to multiply. Okay, so 2 times a times b times cosine of c is all going to be subtracted from your a squared and b squared.
By the way, that quadratic equation song is very useful in the ACT.
I know!
It sticks with you.
Yeah, there you go.
I forgot it.
Oh, boo. That's okay. And then the best part is when you sing it wrong and you thought you did it right. And then,
I just remember the all over to it.
That's the important part.
No, definitely.
So that's the gist of it. All right. So there we go. That's a lot. But either way, we're going to do 11 squared separately, then 5 squared separately, and then that giant chunk separately, and then we'll end up putting them all together. So 11 squared is apparently 121, and then 25 for 5 squared. But then we have 2 times 11 times 5 times cosine of 20. So 2 times 11 times 5 times cosine of 20. It's still fun. Oh, you know what would be even funner? If I turned on my calculator. Okay.
That would
So,
be good.
yeah.
That would help.
5 times cosine of 20. All right. So we're going to subtract 103.3662. All right. So 121 plus 25.
It's not my favorite number.
No, mine neither.
No, my favorite number is 23. What's your favorite number, Lex?
That's 25.
Oh,
Mhm.
why?
I just like it.
Okay.
I don't know. I just like
And then, because you did all that work, you're thinking, oh, good, the side length is 42.6338. But not quite, because the side length squared is that, and so you're going to have to do the square root. So just because it was hard doesn't mean it could be harder. So it is.
Wait, Maggie, what's your favorite number?
This is fantastic.
I'm all about the twos. So
So 2?
22.
Oh.
In fact,
Oh, like
in
222.
in
What's
fact,
that?
in elementary school, we were all given a number that's so weird, sounds really bad.
Wait, so your teacher was just like, you, 23.
Well, yeah, like,
What is the
no,
answer?
it would be like we had 20, we had a classroom set, and so every time, like, you
Oh, okay.
needed whatever
Oh, yeah.
it was, you went to
You
your
had
number.
things that. Wait, didn't you have like numbers on like the back of? I remember having numbers on the back of chairs too. We had numbers on our desk.
Yeah. That's what happens when you only have, 30 of something. So, anyway, mine was 22, so. And I also like the number 2 because it's the only prime even number. It's just like super fancy.
I like
So
23 because I was born on the 23rd.
there you go. So all of these things are lovely. Numbers are great. Yay. Okay.
Like there has to be some reason.
I like multiples of 5 that end
Okay.
with 5. And 25 is a good one.
So that's how you find C. And then it turns out that now that we have the opposite side length, Lex is going to confirm that we can use the law of sines to get the rest of it. Okay? Yeah, if you want to. Because now we actually have the side across from the angle that we were given. But you could also do law of cosines to get any of the angles as well. Just depends on what you like to do, I guess. Huh?
You have to solve for the rest of the
Yes, because it says solve. And so that means every angle and every side length better have a measurement, which, yeah. So slightly quickly, we can revert back to the law of sines and do 6.5295. I wouldn't love doing this because I'm using the answer that I just got in my next step,
Oh, yeah.
which is not always a good idea, depending on how confident you are, okay? And then, so let's say I want to find the B angle measurement. The opposite side is 5. And then, of course, I have to use sine inverse to get the answer. So,
Can I tell a story?
yeah, while I type, sure.
When I was little, for Christmas one year, I gave my sister $12, and my parents were all like, because that's all I had. And they were like, why did you choose $12? That's such a weird number. But in my mind, I didn't think it was weird because it's 6 times 2. And I thought, that's an easy math problem.
It has
That's
factors.
Not, yeah.
I mean, it would be weird if I gave her $13
Yeah,
because that's nothing times nothing except
Yeah.
1 and 13. That's
There
excellent.
There's a Seinfeld episode
Oh no.
where it's Elaine's birthday, and Jerry's like, I don't know what she wants, so he says he's like just gonna give her like $183, and then George is like, what should I give her? And Jerry's like, well, it has to be worth no more than half of what I'm giving her, so he gives her exactly half. It's like $91.50.
Ezra, I have a question. How much Seinfeld knowledge do you have?
I've seen every episode.
Oh my god, my grandparents
Why?
used to watch it. It was
Why
like
not?
the
I
show.
can think of several reasons why.
No, it's an amazing show.
When you're sitting through it the first time, you're like, this is really bad. And then
Yeah.
you go
You
back
have to get
later.
used to it. And
You have to
It's
become
not,
numb.
it's really
Yeah,
good.
you have to become numb to it.
I
So anyway,
feel like it.
That's that. Okay. So, law of cosines to get the side length, law of sines to get the extra angle, And then of course it should add up to be 180 degrees inside of your triangle, so you can subtract from 180 to get your angle A, and then it's officially solved.
Are you supposed to round with 4 or just do first 4?
I'm just in the middle of the problem and haven't gotten to A yet, so I always just keep 4 until the end. It doesn't say anything about what to round to, so I always keep.
Yeah, we usually, once you're doing 4, it's 18315, so you round to 18312. I'm saying, are you supposed to round or not when you're doing 4?
You always round based on the number
Or
after.
theoretically.
I never round.
Yeah, but you
Usually, whenever I round.
Yes, I did. I have 18305.
You robot kids, you're being loud.
Okay, but I just did the full number that's on the calculator for it, that's why.
Yes, and I did the full number. Like, did you retype it or did you use
In my
ink?
head. If you
I
have
don't know. I did too.
cite an example.
Well, we're debating about the last decimal place, but it's all good. Okay. It's close. All right. So anyway, that's your law of cosines. Let's see what else is happening.
You did it.
I hope it's just that.
I know, because I didn't want to take 180 minus 15 point something and 20 point something. So you're going to have to be satisfied with its 154 point something. Okay.
That's just another equation.
I shall never be satisfied with that answer. All right. So next one is the one that I was trying to reference to before I broke it and did a different one that Lex helped us out with. So,
I didn't.
so this one is all side lengths. Yay! Okay. So on this one, we are going to find out what any of the angle measures are, and we get to pick which one because we have all of side lengths.
C.
Ooh, C, excellent choice. So that means that we are going to use the same formula of C squared, and so hopefully you have that written on your formula sheet, and then cosine of AC there. All right, so the C value is 5, and the B value is 7, and the A value is 9. Super. That means that we are going to have 5 squared equals 9 squared plus B squared, 7 squared, minus 2 times 9 times 7 times cosine of C. So this is annoying because now we have to work all of these backwards and find C eventually by using cosine inverse. So, sorry. All right, here we go. So this is 25, and this is 81, and this is 49. And then 2 times 9 times 17 is
That's a,
18
that's
times
a
7.
7.
Yeah, that's a 7.
You said 17?
Those are
Okay.
Those are different numbers.
All right.
Yeah.
Well,
I bet.
I don't know what I said, but I meant that number. Okay. Maybe because in my head I was already doing 2 times 9, and that's 18, and so I just added teen. I don't know.
You said it. I don't even.
Yeah, anyway, I don't know. Brains are great. Okay, so that means that we're going to subtract out the 81, we're going to subtract out the 49, and we're going to get a negative number, which is okay, because then we're going to divide by negative 126. So, I know. So if I subtract out 81 over here, and also because I'm lazy at the same time, 49. Okay, so 25 minus 81 minus 49 leaves us with a left side of negative 105. And that's going to equal negative 120, that's a 6,
Great.
times cosine
Nice
of C.
save.
Thank you. Looks really ugly,
Yeah.
but that's it.
No, it's good.
So notice 126 times cosine, so we get to undo timesing, multiplying.
Undo
You know, sometimes I revert.
Undo time.
just stop it. All right.
Please.
All right, ooh, that's a fraction. Okay, so apparently 5, 6 equals cosine of C. I just didn't want to put the decimal because it had a lot of 3's in it. Not my favorite number. So,
Wait.
5, 6.
Why couldn't you just add 126 both sides?
because it's multiplied by it, so we can't add it.
I don't know how to do basic algebra.
I know, but you know how many people will do that? Almost everyone. So, yep, don't do that. Yeah.
But it's supposed to be an angle, right?
Yep, so then we do cosine inverse of 5, 6.
That sucks.
Okay. So cosine inverse of 5, 6 is a 33.56 degrees. Okay, anyway, so right here. So C, where's that? Right here, so 33.56 degrees. Yay! All right, and now, because we use law of cosines, we can revert back to law of sines and find the rest of the angles. And subtract from 180 to find the rest of that angle. So, again, we took cosine inverse of both sides to get C all by itself. Yay! So, super questions, anybody? Yeah.
What number did you write? I can't see it. It's really small.
Which one?
In the corner of the triangle.
Oh, 33.56.
Remember elementary school when I had those like time tests? Like the
Time
ones-
pad?
Oh,
Yeah, the
Times
ones.
spelling tests? Like the.
No.
I
Oh,
remember.
those
I
multiplication ones.
Yeah.
Oh,
I never had to do that.
you never had to do those?
Or I blocked it
With
out.
the time test?
Yeah.
Those was literally, I would be screaming and crying. Those gave me the worst anxiety.
Those were
They're
so
the reason I have
awful.
test anxiety.
I hated those so much. And they didn't even help. Like now I'll see like 4 times 8 and that's the first thing I think about. It won't be the answer.
You think about the anxiety that you
Yeah,
have.
that I felt when like learning the multiplication, so it takes me longer to do it.
Or you grab a
See,
calculator.
this is what I needed to know for the ACT.
Oh, boo!
There were so many questions where it's like, how do you graph a triangle? Or
A
Circle, yeah.
Oh, yeah, the x squared plus y squared equals r squared.
Yeah, sure, that sounds right.
Oh,
I didn't know
yes.
that.
That was from the end of geometry.
Come on.
It's from
Remember
the
end
circle
of
unit.
geometry?
Chapter 12.
Did you not study for the ACT?
I studied generally for the ACT.
I didn't.
Would you get?
Oh, yeah, like a copy of one or whatever?
Studying is unnecessary.
I'm good.
Well, depends on. I would say that, but Jackson studied for like an entire year and got like a 34. So.
Yeah, I don't need a 34, so.
Alrighty, so taking a look at this formula, that's all it is the area of a triangle. You can find the area of a triangle given the, okay, what am I looking at? Find the area, oh, that's the example.
Excessive.
Okay, so the idea is that you can find the triangle area
Do I have
because it's going,
Sorry.
okay, I'm missing something. A half times the length BC times the sine of A. And even though there's not a diagram with this, which is actually not very helpful, I'm assuming that this is A, the angle measure of that, because this is not a right triangle, right? So all the stuff we're talking about is using trig, but not in a right triangle. And then these are the side lengths B and C, because A would be over here across from angle A, right? So those would be B and C. And then that's the only thing we need to know.
Wow.
Because in any triangle, if I've claimed that this angle I'm looking at is A, then this is side A. And so this has to be both sides of C and B, or B and C. So if we're going to use that in this directly underneath it example, okay, that means that I'm going to have angle A of, what did they say? Find the area of a regular octagon, 8 equal sides and 8, thank you, okay, inscribed inside a circle with a radius of 9 inches. So that means, yep, that those are both 9 and 9. But then we have to find this angle measure, and that is by the fact that it's a regular octagon. So all of this is 360 degrees, but there are 8 pieces of 360 degrees. So what is the measure of angle A? You can do that.
360 divided by 8.
Yes, it is.
45.
Hey, 45, look at you. All right. So, yay!
This feels better.
It's oh,
I
We're
use a-
proud of you.
I use a calculator to divide 360 by 8.
Yeah,
It's
you
more
did.
effort than any of us put in.
Okay, fair enough. Maggie did it.
Yeah, I did. Because I wanted to know when you said it
I
if
can
it was
teach
right.
this. Wow. That's fair, actually.
Nikki doesn't even trust Lex's
I
calculator
wouldn't.
skills.
I wouldn't. I get it.
That's okay. What happens many a times is that I will assume that a student knows the answer because they have their calculator or they have in the general in the past been right, and then I'll use their number, and then the entire problem is wrong. So I try to just do it at the same time. Okay.
No, I get it.
Yeah.
Makes sense.
I've lost my trust. I'm sorry.
That's fair.
It's not you, Lex. It's everyone
It's
before.
Lex.
Even if it was, that's fair.
All right. So remember on this one, we are not going to use law of cosines or sines or anything like that because they're asking for the area. Area has nothing to do with using law of sines and cosines. I mean, it might if you're going to find a missing length of some sort and then do the area, but this is a completely separate area of a triangle formula.
What?
It's a foot and a half.
All right, and so we're going to do a half times 9 times 9. So this number is in 9. And then sine of 45, which is, because we all know exactly what it is, square root of 3 over 2. That's all I got. 9 squared is 3 over 2.
Wait, I've been
One
distracted.
18-inch table would maybe went out to the board that's on top of everything.
There it is. So 7.79-ish is the area of one of those.
40.5, not 9.
But then divided
Well,
by a half?
yeah.
Oh, 80. Good Lord. I decided to add them and then divide. Oh,
Cool.
God. Oh, my God.
Come on, Meg.
I was checking if Izzy was paying attention.
I'm pretty sure it's 27.
0.5. I'm not going to go with that.
Yeah, it's 27. Did I get it right?
No.
Did you just try?
No, I think he's trying to throw me off.
Oh, I square rooted 9 instead of divided by 2. That's what I did.
Let's not make up any more math.
We're
Okay.
really good at math.
So the area
That's what happens when I do these calculations.
is, did they give us inches? Yay, inches squared. Okay. That feels complete
My
now.
eraser doesn't work. It just blurs everything out. So now it's big spots.
Is it one of those hard old erasers?
Wait,
Yeah.
One of the white ones.
is that the area of the triangle?
Of
But it's
one
not
of the
pink.
triangles, yes.
Yeah, multiply
It's
that
pink.
by 8.
It's
Yes.
Is it a light pink?
It's like
Ooh, look at
No,
you.
it's deep pink.
And then multiply by 8 and you get the entire octagon if you want to.
Well,
Woohoo!
not if you want, it's the question.
What?
It says find the area of a regular octagon.
It does!
This is a necessary step.
I'm really on it today.
So am I.
Remember how you
Didn't
guys
do it.
sat and took a test all day? I
I
sat
do,
and
actually.
did grading all day and it messed with
Yeah,
me.
a couple times I thought you were gonna miss the timer.
A couple
Oh
times
yeah,
you
I
did
did
miss
miss the one and said 3 minutes instead of 5.
when I took the ACT, I had Kevin as my moderator.
Oh.
It was actually fun.
There are
You
5
remember
minutes
when
left.
was it?
There it is.
He was an advisor and then.
Now I've actually answered
Yeah,
it.
yeah.
Super.
He was
I
actually
actually got
good.
hold of people on my notes doing it.
Yeah, that's right. No, Kevin was actually really good
All right.
at it. He was cool.
I had Tyler if I brought you that.
Boo. Hell sucks.
Wow, that hurts. Okay.
Maggie was pretty good.
Even though she didn't say that.
I tried not to go
You
off
gave us
script
a-
like at
You
all.
gave us an extra minute at one point.
Yeah, probably because I started it when it was a certain amount of seconds and was I'm not gonna wait until the actual. Yep, I did give you an extra second. Okay, so
The rest of you.
let A, B, and C equal the sides of a triangle. Super. We're going to end up using something called the semi-perimeter. Why? Because that's what S equals in this formula with all of these S's, which are S's and not 5s. Okay. So if, again, you are all of a sudden given a triangle, ABC, and you want to find the area of it, and you can't do the previous example that we did because you maybe don't have any angles. Notice no angles in there, okay? Then you can go ahead and use this formula to find out what the semi-perimeter is. Plug it into Huron's formula. There it is. He did so well. There he is. Now I just want to Google what he looks like. But anyways, Huron. Yeah. Isn't that the name of the lake? Lake Huron?
Lake Huron, yeah.
That was a lot. In my head, I've always said Huron. But
I
that's,
know.
that's right. Yeah.
It's-
I said
Huron.
I said a heron, so.
Well, you're
That's
all
wrong.
wrong.
Okay, well, we're done. So let's go ahead and try to use this. Awesome. So if I want to find the S value, which is the semi-perimeter, I would need to take 13 plus 15 plus 18, and I don't know why I put a parenthesis around it, and then divide by 2. And I'm not gonna ask anyone to do that for me, I'm just gonna do it on the calculator. I'm not gonna do it on the calculator because I forgot to press 8. There it is.
The way I wrote my E in my
23.
notes makes it look like it says Law of Cosines.
So then the area of the triangle,
23.
is going to be that S value, which is 23, now that I've done it and other people have confirmed, minus 13, because that's the A value. And then we're going to multiply that by, whoop, that's a big parenthesis, 23 minus 15, the difference there. And then multiply that by 23 minus 18, woo! And then we'll have the square root of that. I don't know what's happening, but I'm sure it's good. Okay.
Someone broke into the school.
23.
I mean, walked through the front door.
They just pulled really hard and the
Whoever
magnetic
actually saw
gave
where
way.
that happened, this old guy who had been walking outside and looking in front of the school with like his iced coffee, just wandered in.
It did happen.
Yeah, I remember because he was looking outside of our break room and we were like, "Who is that? That's weird. He's weird." And then we were just like wandering around the halls and he was there. It was terrifying. Anyways.
Are you sure he wasn't someone's parent?
Yeah, because they asked him to leave.
Okay.
There's also that person who, like, every time I've mentioned it to anyone, they've been like, yeah, she's mad because she lives right there and people are always hanging out near her apartment and smoking. But that doesn't excuse the fact that she just paces back and forth in front of the school and then
Like during
just
lunchtime?
stare at the chickens for like 20 minutes without blinking.
That's
So-
she's just vibing. And it's like, that's what I do when I get home. Shut up.
Pace and stare at chickens.
Yeah.
I mean,
Defining Anna. All right. So on that note, the triangle area, if you weren't there while I was solving, is the square root of 9,200, and so 95.92.
But it doesn't give
Oh.
you the units, so it's
Yeah.
what, just unit square?
Yeah. So lame, but answer. Yep. I am hoping that we are done now because I'm done.
that'd be good.
This is just more proofs because one year people weren't doing so well on them, and you guys are actually doing really well on them. So moving on.
Are we?
Yeah, like you should try to talk to other people, like
I don't want to talk about proofs anymore.
last year's people. They really needed them.
Wait,
I despise them.
Hey, there's Anna.
All
Yeah.
of the people from last year, like, oh, we love proof.
Yeah.
No.
Anna,
Yeah, they are.
Anna says
All
like
of
that's
them
the
were
only
like that.
thing she enjoyed last year.
What?
Yeah,
Reed has it. Reed doesn't
Okay.
like it. Reed said he
Well, the
watched it.
problem actually was that they loved them after they did them a bunch, because at the beginning there was a lot of yelling. I remember.
wasn't there always a lot of yelling?
Mostly by Lando. Yeah.
Ah, cool.
That's just how he shows his.
I got 100% on the quiz.
Yay!
I never finished it.
Nice.
All right. So now here's your 5-6 assignment. Very exciting. All odds. And when you get to areas of triangles, see if you need to use Huron's theorem or if you need to use the other theorem that I talked about.
What is not more you can use both now?
Yeah, it depends on what's given. Because the one uses an angle and the other one uses just the side length. So it just depends on what's given. And if you want to work extra hard, you can go around the other one.
How do you want to work extra?
Good, actually.
Duh.
How much
I have stuff to do.
I mean, I feel like that's